Hello, bonjour à toutes et à tous. Thank you very much for being here. My name is Gabriel Canteins. I'm head of Prospective and Innovation at SEATURNS and also associate. I'm pleased to be there to introduce you SEATURNS, its technology, its potentials, its futures. So let's speak of, parlons de houle, let's speak of waves today. The wave resource is huge and worldwide. You can see here with the yellow, orange, red color showing the regions in the world where the wave resource is very interesting. This wave resource could meet 10% of the world electric power demand on the longer term. It is available on all the continents. This resource is highly predictable and available everywhere. And it could meet the United Nations Sustainable Development Goals. So this energy was being harnessed. And SEATURNS offers a solution to harness this energy. We developed a very simple and robust solution designed to withstand the harsher conditions at sea. We'll provide this solution to produce a low carbon and low cost energy and to be in phase with the climate and environmental imperatives. And we plan to become a major player in the world of wave energy. We've deposited 3 patents. We are a French startup based in Bordeaux. This is our solution. This cylindrical floater will rotate in the waves. This pitching movement will be transmitted to an inner water pendulum. You can see here, and this solution will create an inner circulation of air. This flux, this in closed circuit, will rotate an air turbine coupled to a generator that will produce electricity. This solution is very compact. There are no moving parts outside the floater. It is all in this sealed volume. Thanks to the mooring solution, we create this oscillating movement. This is one of the crucial patents. One advantage of the solution is the possibility to be installed in a multi-floaters configuration. As you can see here, a typical line of 10 floaters will produce 2 megawatts of rated power. But our ambition is to create larger farms. I'll introduce you the market later. So simple, robust, the possibility to be installed in a large number of places in the world and places where there is a huge electricity potential. This is just a reminder to explain the operating principle. So you can see here this inner water pendulum inside the floater, the air turbine, the generator, and we have a solution to export electricity thanks to a very specific export cable designed to, in particular, withstand fatigue. And on the next slide, this multi-floater configuration with a typical mooring solution. So our innovation in the floater, not in the moorings. And this is also a key point. I mean, to be able to face the strongest sea conditions, we need only a good mooring design. The floater by itself is very simple and robust. Just maybe a word. A typical project would be to install a line of 10 floaters with a water depth of 20 to 30 meters and a typical distance from the shore of, I would say, 2 or 3 kilometers. Not too close because of visual impact, not too far because the cost of the electric cable could increase too much in the budget. One particularity based on this multi-floater configuration is the possibility to install a large power on a small surface. I mean, if you consider 1 kilometer square at sea, we can install 45 megawatts. This is 2 or 3 times bigger than offshore wind turbines, for example. So a reduced marine footprint or a bigger power for the same surface at sea. This is a summary of several advantages of the technology. I already explained nearly everything. Simple, robust, similar to the robustness of a buoy at sea. Possibility to install several floaters, so optimization of the cost of the capex, and higher power for a smaller surface. Another advantage is a very, very good ratio of power, weight to power. I mean, for the same weight, mostly I didn't mention the fact that the floater is steel made. We can produce higher power. This is a good competitiveness indicator. Our test basins showed a very good performance on the very large operating spectrum. This means that we can install our solution on a very large number of locations worldwide. From the beginning, we followed a very strategic approach based on technical performance, but also economic performance. I mean, if our solution is performant, that will have a good, good performance, but costs too much, this solution was not being developed too much so far. And finally, the dimensions. 6 meters diameter, 15 meters long, for 200 kilowatt. This device is not so big, and the consequence is that the visual impact will be quite limited. Our team is one of the best assets. Marie is here. There is also Vincent, the CEO. Marie is Marketing Communication Officer. So we are three here. We have a booth. Please don't hesitate to come and meet us. We are here until tonight, and the complete team is here. So we cover all the aspects of a good team. We are in a raising movement, and I'm very happy to share this adventure with them. One major success recently is the possibility to test our solution at sea. There is before and after, it's not the same. I mean, the possibility to test a prototype at 1/4 scale at sea during more than 1 year is a major step for a technology developer. We conducted those tests in partnership with Ifremer at the entrance of Rade de Brest for 1 year and a half. We faced a major storm. We could measure good performance, good stability of the device. We could show that it is possible to install this solution with very light means. I mean, you can see here a quite small boat with a team of 3 divers. Those means was enough to install the device and to conduct the maintenance. This is essential for us to have this possibility to install and operate a solution with means that we can find everywhere in the world. We don't need a huge ship, huge crane, etc. So the impact, the consequence will be the possibility to harness energy everywhere. I just need to check the time. Okay, those are a few pictures about those sea trials. You can see here the preparatory phase. We conducted tank tests just before the installation at sea, and then we installed the mooring lines, the dead weights as anchor solution, and then we could deploy the device with those very light means. Several steps, the sea launch, then we filled the cylinder with a water pendulum. At this scale, the cylinder is 1.5 meters diameter, 3.6 meters long, and there are more than 2 tons of water inside. And we installed the device. It faced several storms. We had a good monitoring of performance of images at any time, day or night. And we faced, in particular, this very famous storm in Brittany called Kiran. in November 2023, and there were not any consequence of the floater. Good behavior, good performance, good monitoring of performance. So a very good success for us. Now we move on to the next phase. We are ready to build a full-scale demonstrator. You can see here our solution. It is a 200 kilowatt rated power unit. The dimensions, 6 meters diameter, is roughly the size of this roof, and 15 meters long, nearly 15 meters long. You see here in yellow the floater. It is steel made and nothing else. Only steel, no moving parts, no electronic parts. All those equipments with added value are concentrated in the white part called the PTO module turbine. And this will concentrate the air turbine, the generator, electronical equipments, and also valves to adjust the airflux. This solution, very simple, robust, designed to withstand the most hostile conditions. And it offered a reduced capex, footprint. This unidirectional turbine offers good performance as compared with a bidirectional turbine. It exists, but we prefer to choose this solution. This device, this concept is based on several patents. We today have 3 patents, and in particular for the power takeoff. This demonstrator is nearly, the manufacturing of this demonstrator is nearly completed, and it will be installed from this summer, probably August or September, at sea in a testing site called SEMREV. It is operated by Fondation Open Sea, located about 20 kilometers from the shore, Le Croisic, and will test a single floater for more than 1 year, probably 1 year and a half. And the objective is to reach the TRL 8 and to offer good projection toward commercial pilot farms. This is also a major objective today. Let's speak of the business model. As I mentioned, we'll divide our solution in 2. In yellow, the floater. In white, the PTO module. And our business will be based on those 2 parts. On the shorter term, we'll focus on offshore microgrid solutions to provide rated power lower than 25 megawatts. In this case, SEATURNS will offer a full wave energy converter system. So it will be dedicated to industrials, small industrials, but also islands, isolated networks, isolated sites. The idea is to provide a competitive solution for those sites. On the longer term, as we don't have a very specific added value on the manufacturing of floater, we'll focus on the PTO module and work with a partner to manufacture the cylindrical floater close to the future sites of installation and operation. The idea is to have a massive impact on decarbonization and to have the possibility to install this device everywhere in the world. So the PTO module will be the key component of SEATURNS technology and will focus on the performance of this module in order to install large utility-scale projects with power larger than 25 megawatts. This solution will offer electricity to supply electricity to several activity sectors, isolated networks and islands, and maybe tourism on the short term. But the objective is to quickly move to a larger market that of grid electricity, green hydrogen, power to X, remote offshore operations, harbors, marinas, etc. This electricity will then be produced by larger farms, larger wave farms. I already showed this map, but I wanted to show it again in order to explain that there is a huge market, a huge potential available everywhere. We'll focus on the western coast of Europe, on the south of Africa, Indian Ocean, Australia, Oceania, on USA, Canada, Chile. But there are also possibilities in other places because our solution could be competitive even in smaller sites with maybe a smaller value of wave energy. But in this case, the solution might be competitive. It will depend on the solution available on this site. So please don't hesitate to come and meet us. We can discuss future projects. The future will be based on the installation of several pilot farms. We are currently working on the demonstration at full scale, and then from 2026 or 2027, we'll install the first wave pilot farms. We are currently discussing with some partners, and the objective is to deploy as soon as possible those farms. The idea is to show that, yes, there is a good potential with wave energy, and we want to complete this demonstration as soon as possible. It could be in the Indian Ocean, it could be in Europe, maybe in France, it could be in Ireland. There are many sites interesting, and we are ready to deploy this solution. On the longer term, after the wave pilot farm, we'll focus on the, in particular, national grids and this very specific business model based on the manufacturing of floaters close to the future operational sites and the manufacturing of PTO, power takeoff module. To conclude this presentation, this speech, we are currently looking for clients, of course, local authorities, ports, industrials. Please don't hesitate. And we are also looking for players in the value chain. And of course, if you want to know more, if you want to discover us, to know more about the solution, if you could be a technical partner or a financial partner, we are here at the booth C13 in Nouvelle-Aquitaine region. Marie is here, Vincent is here, I'm here. So I was very happy to introduce SEATURNS, its technology, and its huge potential. Thank you very much. And if you have any questions, please don't hesitate, nor or just later. We'll be very happy to answer you.
Yeah, great presentation, by the way.
It's okay.
Yeah, yeah. Hello.